Hello and welcome to FISHTORY. I'm Alexander Williamson, and today we are talking about the terrible tragedy that is befalling coral reefs all around this planet, which is bleaching due to hot temperatures. So we will talk about what is going on in the barrier reefs off the coast of Florida, in the Florida Keys and southern Florida, as well as what's going on with corals as a whole, and what sun bleaching is, or what temperature bleaching is at a cellular level, and why it is so destructive to coral, and what the implications are for reefs at large and reefs in the future. So today, over 500 million people rely on coral reefs to survive every single day, whether it is harvesting food in the form of fish or shellfish, kelp or seaweed, relying on the reefs for ecotourism and beautiful artwork, the latest and greatest pharmaceutical wonder drugs that are found in creatures and different organisms that inhabit the reef, or the next miracle material that we engineer by studying evolutionary processes that we discover on the reef. Reefs are a crucial ecosystem everywhere they are found, and unique everywhere they are found. They are so unique and so crucial that 29 of the world's reefs have actually been deemed UNESCO World Heritage Sites worthy of protection and preservation by the United Nations. However, things are not looking good for the beautiful and biodiverse coral reefs around the globe. Estimates by the World Wildlife Fund and NOAA predict that by the year 2050, over 80% of the world's reefs will be dead and gone. When compared to their range in the mid-20th century, 60% of the reefs are already gone. Even more alarming, these groups of scientists predict that by the year 2100, there will be no coral reefs left on this planet. When looking at Australia, since 2015, half of the Great Barrier Reef has been lost. And predictions I just mentioned about the reefs disappearing completely by 2100, those were made in 2016. It is now abundantly clear that our reefs may not even survive the next 50 years, let alone 75. Less than 0.08% of all the world's oceans and seas are home to coral reef ecology. Yet these complex and magnificent ecosystems, made up of thousands of different organisms ranging from single-celled creatures to the largest species on the planet, are home to 25% of all the world's biomass in living organisms. They also make up the most biodiverse and beautiful ecosystems in the world, on par with the tropical rainforests. In the Florida Keys, ocean temperatures have been unusually high lately, with one location hitting a staggering 101.3 degrees Fahrenheit this week in late July 2023, and another buoy off Vaca Key that has been seeing steady temperatures above 93 degrees Fahrenheit, a full 5 degrees Fahrenheit hotter than the normal reading this time in July on average. In July, the average temperature for the area should be around 88 or 89 degrees, with the average for the Caribbean holding at 89.1 degrees for the 20th century and thus far into the 21st century, according to NOAA. Nearby Peterson Key in the Florida Keys also saw temperatures above 94 degrees on Monday, and even farther north in Butternut Key, they saw temperatures above 96 degrees. NOAA has raised its coral bleaching warning system to the highest level for the Florida Keys out of the 5 different warning levels that go out to biologists and ecologists around the world, and it's expected to remain that way for at least 9 to 12 more weeks. According to the Associated Press, such an alert means that the average water temperature is at least 3 degrees Celsius above normal for at least 8 straight weeks to reach this alert level. This level was reached last August, but then faded away in September, and the bleaching event was averted. Bleaching events typically peak in late August or early September, but this is the first time on record that we are seeing this bleaching occurring before August 1st. Florida Keys National Marine Sanctuary Research Coordinator Andrew Muskegee said that Florida's coral reefs run more than 350 miles continuously along the southern Florida coast and along the Florida Keys. They protect the peninsula from storms, and they provide a staple for the state's tourism and food industries. According to the state, the system supports more than 71,000 jobs in Florida alone and generates over $6.3 billion for the Floridian economy. Without it, the state will suffer economically throughout the year as well as during hurricane season, which will bring increasingly catastrophic storms when the natural protection of the barrier reefs are no longer there. We are at least a month ahead of time, if not 2 months ahead of time, said Bruckner, adding that the Florida Keys have lost between 80 and 90% of their reef system in just the last 50 years. The Upper Keys have not seen as dramatic of declines as what the Coral Restoration Foundation saw in the south of the Keys in places like Sombrero Reef, but the foundation said that what they are seeing underscores the urgency of addressing climate change. Living corals are like a sandbar or a retaining wall that can flex and move, and also serves as a habitat for countless marine organisms, as well as those coastal ecosystems that reach onto land. Perhaps the most amazing part of the coral reef, beyond its beauty and biodiversity, is its inherent ability to heal itself over the eons, as well as its ability to grow into new locations over time. However, with the current barrage of disasters, from temperature to oil spills and nitrate pollution, reefs around the world are no longer able to morph and adapt and survive. They are reaching a breaking point and snapping and dying, being reduced to fragile arrangements of calcium carbonate, nearly devoid of living organisms and no longer able to hold back storm surge waves, tsunamis, and high tides that are ever intensifying as water levels rise. So what's going on? Why are these ancient coral reefs, some of which are hundreds of thousands of years old, why are they dying? Let's take a look up close and examine what is taking place at a cellular level and at a systemic level on the reefs that are being bleached. Coral bleaching is what we call it when the diverse group of organisms known collectively as corals suddenly lose a key partner in their life cycle and biology. Now, to understand this, we must first understand the anatomy of coral. Almost all corals are made up of several different types of tissue. They are first made up of a calcium carbonate skeleton, which is old layers of living tissue that has mineralized as the reef forms over eons and thousands of years. And then there is a living layer of tissue known as polyps that are a colonial organism of either single cell or simple organisms that all live together as a multicellular colony, feeding on plankton and various nutrients within the ocean's water column. These polyps, however, cannot survive alone. They have evolved with a partner in their life cycle, which is a unique type of algae known as Zooxanthellae. And these Zooxanthellae are dinoflagellate algae that both protect the coral polyps and the tissue of the polyps from sun and waves, as well as from shifts in pH and lack of nutrients, or periods when the polyps cannot feed otherwise. In return, the algae also receives nutrients from an inorganic standpoint. And together they live in a symbiotic relationship that has evolved over eons. Now, coral bleaching is when the corals become stark white or beige because of various stressors, whether it be an increase in temperature, too much intense UV light, or an overabundance of nutrients like ammonia, nitrites, and nitrates in the water from agriculture or different industrial sources. Bleaching occurs when the coral polyps expel that key layer, that key component for survival, their algae layer, and despite it being a desperate measure, it is actually an evolutionary defense mechanism for the corals because of two reasons. The algae act sort of like a life raft, going out into the ocean currents and hopefully finding new, fresh coral polyps to be a host. So they will find young coral that need more algae added to their surface layers, and hopefully deeper in the water or farther north or south, east or west in the water, there will be a cooler pocket or a less acidic pocket of the oceans in which these algae can attach and then stage a new home base. Once this occurs, the hope is that the algae will then split and reproduce, and eventually it will even be able to send cells back into the water and recolonize the skeletal structures of the once dead and bleached corals elsewhere. However, if corals reach too far into this process, the polyps also die, and you are left with a lifeless skeleton of calcium carbonate. It is no longer surrounded by the living colonies of tissue known as polyps, and another layer of cells generally forms, and it is a harmful algae or cyanobacteria that is taking advantage of the nutrients on the surface and generally infects any last living coral polyps or cells. Altogether, this creates a contained ecosystem of sorts that exists within each type of coral. There are different roles played by the surface layer, the internal layer, and all the different tissues that make up a coral. Each species has evolved uniquely and has unique relationships to one another in order to make a healthy and happy, stable, living coral reef. As mentioned previously, this is actually a defense mechanism when the polyps eject the Zooxanthellae algae off of itself, because Zooxanthellae algae actually can die in these conditions as well, and it will produce peroxides and free radicals as well as oxidants that cause cell death in the polyps. So, not only does jettisoning this algae produce the hope of seeding other corals in the region, but it also reduces the structural damage to the polyps and tissue that is living in the now bleached white coral. Once the living tissues of the coral die, the exposed skeletal structure and the dying polyps become colonized by blankets of harmful algae and cyanobacteria. These cause the coral to turn from a white color that is known as the first stage of bleaching to a dingy brownish color, or sometimes even a green or yellow or even black color, as more harmful pathogens and detrivores start to chip away at any organic matter left on the corals. The Zooxanthellae are photosynthetic, and as the water temperatures rise, they begin to produce reactive oxygen chemicals such as free radicals and peroxides. These add up in the waters surrounding the coral, and they begin to destroy even more living tissues and become even more toxic, adding to eutrophication and dead zones in the coral reefs. This causes a feedback loop and causes more of the Zooxanthellae to be expelled from even healthier corals that can survive even hotter weather. So since the Zooxanthellae produce the majority of coral coloration, the coral tissue becomes transparent, revealing the skeleton below made of calcium carbonate. Now, these cells are living components of the colonial organisms we think of as coral, and without the algae known as zooxanthellae, the entire reef will die. Once the corals have died and the harmful algae and pathogens take over, all that remains is the skeleton of the reefs. Sometimes they will retain colors such as blue, yellow, or pink, but this is only due to pigment proteins locked in the calcium carbonate and does not correlate to any sort of survival during bleaching events. Most bleached corals appear bright white or brown, but this phase is temporary, as over time the coral's cellular matrix will break down into smaller and smaller pieces as eutrophication sets in and waves erode the now no longer self-healing or flexible corals. Add in the toxic impact of excessive nitrates from agricultural runoff and the massive increase in nitrogen and ammonia that was unleashed at the turn of the 20th century as humanity discovered how to produce massive amounts of nitrogen for fertilizers on land. These fertilizers and ammonia, nitrates, and nitrites are washed out to sea via rivers and rainfall and groundwater, and the destruction unleashed by these events is amplified by the hot temperatures, the higher water levels, and the acidification of the oceans, which are all occurring simultaneously. Likewise, in the region of the Gulf of Mexico, there are already massive dead zones caused by the nitrogen overabundance that has washed down the Mississippi from agricultural farms and landmarks upriver. You are starting to see alarming die-off events every year, such as this year's 7,500 square mile eutrophication dead zone, where oxygen is depleted off the coastal waters of the Gulf Coast and barrier islands of Texas, Louisiana, Alabama, Mississippi, and the panhandle of Florida. All of this is also compounded by hydrocarbons such as crude oil and petroleum byproducts that are released during drilling and transport of oil. Now, I should mention that the Earth and its oceans naturally do leak some amount of oil and hydrocarbons, but generally this is occurring in deep ocean vents, and it is at a fraction of the scale that humans have created since they started drilling and prospecting for oil around 120 years ago. Within months of the corals dying from this bleaching in the hot ocean waters, the constant onslaught of nitrogen and hydrocarbon pollution flowing along the Gulf Stream and up the East Coast begin to solidify and amplify the death and destruction that we are seeing during these bleaching events. Historically, coral and its living components are flexible structures that heal themselves. However, we are not seeing them able to keep up with today's threats. While others used to regrow and reform, altogether this is known as a coral reef, and over time these structures morphed around islands and formed new barrier reefs and sandbars, and they protected the mainland and shallow marine ecosystems from damage from the ever-predictable seasonal hurricanes, the occasional tsunami, and now the rising tides that are occurring as ocean levels rise and increase erosion on the shorelines. Beside being a beautiful home to so many diverse marine species, the loss of these reefs will ultimately impact the nearby terrestrial marine ecosystem as well as billions of humans. As yet unknown chain reactions and collapses of the oceanic and global food web begin to deteriorate and show their face. This is a crucial problem that we will be facing in the 21st century. And even though scientists are creating a sort of Noah's Ark trying to save young polyps and frags in Florida aquariums in warehouses, in massive facilities, it is still not enough to stop the damage that's occurring, where they're seeing 100% total destruction and death with no hope of rebounding in the reefs off the southern Florida Keys right now. It is a sad situation, and something drastic will need to change, or innovation will need to come, if we hope to stem the tide of this terrible, terrible occurrence. Thank you so much for listening. If you like these episodes on current events going on in marine ecology, biology, and all sorts of things in the fish hobby, aquaria hobby, then please hit that thumbs up button. You know what to do. You can also become a member for only $1.99 and get access to 180 extra episodes. All of it is so sincerely appreciated, and I can keep doing these deep dives and different up-to-date breaking news stories where we try to get some context on what's going on in our rivers, lakes, and oceans around the world. Thank you so much. Have a great day, and I'll see you next time on FISHTORY.